Today in Algebra 1, we started learning about slope-intercept form. And in particular, how to graph using slope-intercept form. So part A is how to graph if you're just given all of your information. For example, number 1, if my slope is equal to 3/4 and my y-intercept is -3, how can I graph that? Now, for slope-intercept form, the important thing that you realize here is I have to have a slope and I have to have the y-intercept. A lot of people today were asking, well, why not the x-intercept? Well, because that's not how the formula works. So we need the the y-intercept and the slope to make this happen. Each time I'm just going to start by going 5 each way. I may need to add more, but it's just a good starting place. I'm also always going to start by graphing the y-intercept first on the y-axis. I'm going to go down 1, 2, 3, and that's my y-intercept. Put a point there. And then I'm going to use my slope to get 2 more points. So my slope is 3/4. So from here, I'm going to go up 1, 2, 3, and over 1, 2, 3, 4. Make a point. And then I'm going to do it again at 1, 2, 3, and then over 1, 2, 3, 4. Notice I didn't have any lines here. I just kind of had to kind of go with and count it out. And then I can connect those 3 points to make a line, and I need to do that. And then I've graphed my ordered pairs. Let's write the steps out to the side in your Cornell section. Step number one was to graph the y-intercept. On the y-axis. Step 2 was to use the slope to count rise over run. Use the slope to count the rise over the run. Step 3 is to graph 3 points and connect. Now, I could always do more points or less points, but 3 is a good number to get a pretty good graph, and for my class right now, that's what I want you to do. Let's look at another example of how to do this. Example 2, if the slope is -3 and the y-intercept is equal to 5. Okay? Okay, my slope isn't a fraction, so that's a problem because we need it to be so we can count. So we're going to put 1 on the bottom. We're going to start with our y-intercept, which is 5. 1, 2, 3, 4, 5, and I just barely gave myself enough room there, but I do have enough to do that. And then my slope is -3 over 1, so I'm going to go down 1, 2, 3, and over 1. And do it again. Down 1, 2, 3, and over 1. Notice that when I go over, I'm always moving to the right. Okay, that's very important. You should be doing that as well. And then I've got a line, so I've got everything I need. My graph is done. Part B for today is to use the slope-intercept form. If I'm given the slope-intercept, and I'm just abbreviating that SI for now, to graph. Let's go ahead and get a definition for slope-intercept form. And that is if a line has a slope M and a y-intercept B. Then the line is y equals mx plus b. You may have heard that before, that y equals mx plus b. That is very important. It says any line where I get it to say y equals, the thing right in front of x is the slope, and this is always the y-intercept. Now, why it's called b, I'm not going to go into, but it is always called b. That stands for y-intercept. There is no special name for the x-intercept, just the y. And again, I'm not going to go into all the reasons for that, but you just need to understand that m is slope and b is the y-intercept. So let's look at some examples involving this. Example number 3. If m, actually I'm going to give you the whole equation and we'll figure out the m and b. Okay, y equals -1/3 x plus 2. We need to pick out the m and the b. The m is right in front of the x, so that's -1/3, and the b is 2. And now I have all the pieces I've had every other time I've graphed, so I'm going to go ahead and do that. I start with my b, which is my y-intercept, and that's at 2, so I graph that. And then from there I use my slope and I go down 1 and over 1, 2, 3. And then I do it again, down 1 and over 1, 2, 3. And then I connect my line. Let's look at one more example. This one's a little bit more complicated because there's some algebra, some figuring you have to do before you can get it into slope-intercept form. Right now this is in what we call standard form, meaning the x and the y are on the same side. I want it to be in y equals mx plus b, which means the y has to be by itself. It's not right now, so let's work towards getting it that way. You should notice that y is being multiplied by 2 and added by 6x. So the inverse would be to subtract 6x from both sides. And then I have 2y equals 10 minus 6x. Now, it'll be better if you'll go ahead and write the x first. So let's do negative 6x plus 10. Okay, so that we'll have it in mx plus b form. Now, y is almost by itself. The last thing I need to do is divide both sides by 2. And so y equals, and notice I divided each piece by 2 so that I could reduce. Negative 6 over 2 is the same as negative 3 over 1, x, plus 10 over 2 is the same as 5. I want to leave this as a fraction because that's my slope. So my m is negative 3 over 1, and my b is 5. And in fact, we've already graphed this one once today. I'm going to start at 5 and go down 1, 2, 3, and over 1. And down 1, 2, 3, and over 1 again. You can connect those lines, and now I have a nice line. And that's it for today. Your assignment is page 338, numbers 1 to 6, and a worksheet about the bank, one of those riddle worksheets. I want you to do 1 through 6 on the back of your worksheet that I give you, and then I want you to show me those, make sure you're on the right track, and then finish the front side, the bank worksheet. Let me know if you have questions.